So the next alkaline rock would be Lamprophyres that we'll be covering. So the term Lamprophyre, it was okay. So starting again. So Lamprophyre, the term Lamprophyre, it was introduced by Gumbel to describe the group of dark-colored dikes from the Germany. It has been derived from the classic Greek word lampros, which means bright, glistening, of the rock of type area contain prominent flakes of lustrous biatites. Lamprophyres are defined by IUGS subcommission as follows. It is a distinct porphyritic in mafic mineral, which means that it is formed by two stages, typically biotite, amphibole, pyroxenes, feldspar being confined to ground mass and occur as a dike, small intrusion, and often shows the sign of hydrothermal alteration. So, traditionally, they are distinguished by based on the following characteristics. So, normally they occur as dikes, and they are not simply textural varieties, common plutonic organic. They occur as dikes. Next, they are porphyritic with M, that is more than M% mafics, typically 35 to 90, but rarely more than 90. Feldspar and feldspathoids, they are restricted to ground mass and usually contain essential biotite, phlogopite, amphibole, CPX, and olivine. Hydrothermal alteration of above mineral is common. Calcite, zeolite, hydrothermal minerals appear as primary phases, and they tend to have K2O, Na2O, H2O, CO2, and etc. So, Lamprophyre was classified by into three types by Strachan, that is Stracke-Kaizen, that is in 1980. Calc-alkaline Lamprophyres, that is SiO2 is 50 to 54%, alkaline SiO2 is bit less, that is 38 to 44, and mellitic, that is SiO2 is less than 30. And Rock prefer to call mellitic lamprophyres as ultramafic lamprophyres instead, arguing that the millet-free and millet-rich varieties commonly coexist. Okay, so this is the three calc-alkaline, alkaline, and mellitic. And you see how malolite and biotite when is present in mellitic, so the term is given on the basis of that. Now, the latest attempts by the IUGS subcommission to classify the mellitic rock consider them as a variety of separate mellitic rock group and not lamprophyres at all. Now it is totally different. Calc-alkaline lamprophyres consist of minnette, vogasite, kazantite, and spessartites. So they occur in subduction zone environment, and then generally they are in associated with the calc-alkaline granitoid suits or more alkaline socianites. Okay, now so the four common lamprophyres are most rarely classified using model data, and the mineral data characteristically present in the rocks include orthoclase, oligoclase, andesine, biotite, phlogopite, diapside augite, hornblende, kazerutite, and olivine apatite. These all are the minerals. Okay. Now, okay. So alkaline and the mellitic lamprophyres contain alkaline rocks and are usually associated with alkaline complexes and the rocks of carbonatite, nepheline, izolite association. According to the Stochastic same person, the common alkaline lamprophyres are camptonite, sienite, and monticoites, and they are chemically akin to alkali basalts, basanites, and nephilites. So they typically occur in interplate and in rift environment. So about them, so camptonite is most common alkaline lamprophyres and it creates phenocryst, gazeretic high TO2 and vibratic high Fe, amphibole, titanite. There is a very so many terms are over there. So if you barely remember the name, okay, sinites are similar to camptonites, but plagioclase is subordinate to cave. This information is something if you can hold, then it's okay. Otherwise, just try your best. At lower silica, melilite becomes an important mineral taking place. Pyroxene, this gives rise to alnoite, which is composed essentially to phlogopite, melilite, olivine, tadangite, monzicellite, FETI, calcite with accessory nepheline, apatite, and perovskite. So alnoids are remarkable in that they are rich in both Mg and K, and it's a characteristic shared with kimberlites. So lamprophyres, by increase in olivine and decrease in augite, some alnoids grade into kimberlites. So there is a gradation from alnoids to kimberlite as well, or mental peridrites. Others, by increasing content of carbonates, pass naturally to into carbonatites that still carry olivine, melites, apatites, and accessories. Polzenite is a mellitic lamprophyre that usually contains between 10 to 30% falsipathoids, and it is normally contains the same mineral as alnoid. So this information is quite difficult to digest, but it's okay if you remember. Okay, what was polzenite, etc. So lamprophyres high volatile content, particularly H2O, and resulting abundant mica amphibole phenocryst as are the predominant uniting characteristic of the group. So just remember we have the high volatile content and resulting abundant mica amphibole are the predominant uniting characteristic of the group. The implication of is that lamprophyres develop as a consequence of volatile retention via crystallization at high pressure or by prolonged normal differentiation process. If so, many lamprophyres may be nothing more than the high-disk crystallization products of common magma types that occur unusually H2O rich conditions. So they're still worth considering, however, because they record part of the long-term evolution of some magma chambers and the mechanism by which such high-risk variants are accomplished are both interesting and averse. So depending on the initial magma type and the condition under which it crystallizes. So in Indian occurrences, in India, lamprophyres are mostly studied from Gondwana basins and they have been reported as mica traps from the Indian coal fields. From Raniganj coalfields, minette, carnotite are the most frequently reported types. Leucitites, microcyanides, and quartz carbonate rocks occur in association. Monshierite is reported from Mount Ginnar. Calc alkaline lamprophyres are reported from Mundwara complex of Rajasthan. Ambaragar carbonatite complex Gujarat is included by camptonite and carnotite. So yeah. Okay, just a minute. Okay, so okay, petrogenesis of lamprophyres. So I've already told you lamprophyres is something that is characterized by high content of mafic minerals and it is often associated with high potassic magmatic system. Lamprophyre is a mafic igneous rock that is typically potassic and contains the biotite, hornblende, and pyroxene. They are often considered hydrous and sometimes they exhibit a porphyritic texture with a large crystal embedded in finer matrix. Silica content. So generally low to moderate, 45 to 55% of SiO2 is there and it indicates a mafic composition. Mineralogy. Primary minerals are there: biotite, hornblende, pyroxene, feldspar, and mica. Accessory minerals: magnetite, apatite, calcite, zircon. Mafic to ultramafic, they are characterized by significant amount of mafic minerals and can be classified on the basis of specific mineral assemblage. Petrogenesis of lamprophyre. So the formation of lamprophyres involves the partial melting of mantle. They are followed by differentiation and crystallization. So mantle source, they originate from lithospheric mantle derived, and they are enriched in alkali metals NaK, H2O, and CO2. Magma sources. The mantle sources may include laherzolite, eclogite, that is metastomite by fluid enriched in volatiles, leading to the generation of potassic magma. Partial melting. Lamprophyres are produced by high degree of partial melting and particularly in environments potassic and carbonatic magma are generated. It's a volatile driven melting. So enriched volatile components like H2 and CO2 lower the solidus temperature. They promotes the potassic melts that crystallize with high content of mafic minerals. Now magmatic differentiation. After initial melting, the resulting magma undergoes differentiation. It leads to the formation of various mineral phases: biotite, hornblende, pyroxene. Porphyritic texture. Lamprophyres often display a porphyritic texture, and where the large crystals of biotite, hornblende, pyroxene are embedded in fine-grained matrix. Crustal interaction. As the magma ascends towards the earth surface, it may undergo assimilation of crustal material and fractional crystallization. So this interaction can influence the final composition of lamprophyres with the addition of minor amounts of feldspar and other crustal materials. Okay, eruption and intrusion. So lamprophyres can be intrusive, forming dikes and cells, extrusive, and they're generally more common as intrusion like dikes and cells. Lamprophyre dikes are often found in continental rift zone, subduction zone, where mantle upwelling occurs. Tectonic settings of lamprophyre formation. So lamprophyres are typically associated with active tectonic environment, and the mantle generates high potassic magma. That includes the subduction zone, continental rift zone, and interplate settings. Geochemical characteristics. So we have in major element we have high K2 and Na2O and low SiO2. And trace elements, they are enriched in LiLes. So large ion lithophile elements Rb, K, Ba, K, and Sa, and they are depleted in HFSC, and they have the high MgO and FeO. So isotropic signature, SRND isotopes. Lamprophyre shows isotropic characteristics that suggest a mental derived origin, with SR and ND isotopic ratio reflecting relatively low crust contamination. So unique features, they are potassic nature, and porphyritic texture is a unique feature present in it, and it is hydrous. Please remember that as well. And the association with mafic and alkaline magma. So lamprophyres are often linked to alkaline and ultrapotassic magmatic suits, and they are, they often occur in tectonic settings involving mantle and upper lake subduction zones. Economic significance, they are not widely mined. Lamprophyres, they are host valuable mineral deposits, and those related to precious metals and rare elements in some geological setting. Lamprophyres dikes in mineralized zones, especially in arc settings. So classification, I've already told you how many classification are there. So I don't think that I need to do this one. We have the geochemical relation and discrimination, so BA and RB. So they are more potassic in nature. High ratio indicates that. TI-ZR, it's a low ratio, so there's a depletion of HFSC. And LA-YB ratio suggests high mental metastomatism. So example of lamprophyres are there. So quick revision points are, so definition is mafic potassic igneous rod containing biotite, hornblende and pyroxene, originate from mantle derived magma. And the tectonic settings, I've already told you, porphyritic textures with large mafic minerals, and they occur in active tectonic settings like subduction zones and hotspots. Thank you.